The previous presentation was presented in one of Myema's programs 3 weeks ago. So it is available to you on the website of Myema. I was afraid that I might find people who have been to that presentation and they would get bored if I repeat the same presentation. So having had some time to talk a bit about the myths of photovoltaics in Malta, I thought it would be a good idea to also tackle that topic, especially because last year in Enerscapes, I have been talking about the socio-economic aspects of photovoltaics. So I thought to stick to the same topic. So you haven't missed anything. If you would like to see the other presentation about renewable energy, past, present, and future, just ask and they will let you know where to find it on their website. So today I'll be speaking a bit about the myths of photovoltaics, how people tend to make certain conclusions, certain statements. I need to sit down because they told me to sit down because of if I move a lot, the microphone will make noises. So I hope that's fine for you. Let's start with what we call the kilowatt peak. We always hear, especially these days, because we have these government grants coming up, and everybody is quoting prices per kilowatt peak. A kilowatt peak is a standard way of reporting the capacity of a PV system. The word peak is related to the peak solar radiation, which is normally 1,000 watts per square meters, and it only occurs at specific times of the year, naturally on clear days, mostly in summer, and definitely around noon time, not at any other time. So we are talking about peak power of a PV system that only occurs at a specific time during the day. The conclusion of this peak power is that we cannot consider a photovoltaic system as equivalent to a generator, a diesel generator, for example. If I have a diesel generator rated at, let's say, 50 kilowatts, then if you put fuel into that generator, it will run and it can give you 50 kilowatts all the time, 24 hours, as long as it is running. In the case of the sun, the fuel, in the case of photovoltaics, the fuel is the sun. The sun is not constant, and therefore the output is not constant. Now, some PV modules can be more efficient than others. One is 15%, the other is 19%. But when we talk about kilowatt peak, we are taking away from our equation efficiency, because even if you use less efficient photovoltaics, the only conclusion is that you need more panels to come up to that kilowatt peak. Let's say one panel measures 2 square meters and produces 200 watts. So to get 1 kilowatt peak, I need 5 of these modules. And because the area is 2 square meters, 5 modules will occupy an area of 10 square meters. If these modules were less efficient, I will simply need more area. So the trick of kilowatt peak is that you no longer talk about efficiency, but then remember, the area will change. Now, when we come to Malta, we have been carrying out tests at the Institute for many years now. The first test was based on a standalone system with battery storage in 2003. Then it was followed by grid-connected system between 2005 and 2011. Then we also tested systems that were actually installed, newly installed in certain sites. And you always come with similar outputs of roughly 4.2, 4.4 kilowatt hours per kilowatt peak per day. Or what we call, if you want per year, it's around 1,500 kilowatt hours per kilowatt peak per year. Some systems, especially when they are still new, they produce more because the degradation of these photovoltaic cells didn't kick in. But obviously, by time, the long-term output of a PV system operating in Malta under the conditions of temperature and sun is roughly 1,500 kilowatt hours per kilowatt peak per year when installed at 30 degrees to the horizontal, the standard way as we see it nowadays. Now, if we go on a monthly basis, you can see that the output per day, of course, varies because the potential of solar energy is different for each month. And that's what we call the final yield, kilowatt hours per kilowatt peak per day. The minimum you can get out of 1 kilowatt peak is around December. You only get 2.73 kilowatt hours per kilowatt peak, while around June, you get the maximum, 5.16 kilowatt hours per kilowatt peak. So you can see this is energy now, how much your system is producing into your electricity meter. And of course, if you don't want to pay electricity bills, you have to try and match the load, the consumption of your house to your actual production from photovoltaic systems. Luckily, photovoltaics is in tandem with the need for cooling. In summer, you need cooling, so now you can switch on your air condition, or at least this is one of the myths that we will talk about. But before going to the myths, let's see about what's about the inverter, which is the heart of the PV system. The inverter basically converts DC voltage, which is being produced from the photovoltaic modules, into AC voltage, which is useful for electricity appliances that are normally used in our households. Now, if the inverter is undersized, you are actually restraining the maximum potential of the system. The inverter has to match the peak power of your system. We say roughly plus or minus 10% will be fine. Sometimes, I don't say that I have any proofs, but sometimes in competition, unfair competition I would call it, it could happen that suppliers give you a smaller inverter because it's cheaper, but more panels. And therefore, you think that this system is cheaper than the other. But because the heart of the system is smaller, eventually you cannot produce the same power as a similar system. So these are things that one should be careful about. And we start with the first myth, where we talk here about how much a PV system can produce in Malta. Now, we say, from a research point of view, the long term is 1,500 units of electricity per kilowatt peak per year. At the beginning, when they are still new, you can produce 1,600 kilowatt hours per kilowatt peak per year. And what makes a PV system drop in output? It's not only the degradation of UV, but also the operational temperature. Because we are a Mediterranean country, because photovoltaics have a dark color, their operational temperature is roughly 45 degrees on average over the whole year, going up to 60 degrees or even more at peak noontime in summer. And even in winter, when it is cold, at noontime, you don't get anything less than 35 degrees as monitored by our systems. Now, when we talk about the kilowatt peak of these systems, they are all measured at 25 degrees. Anything above that temperature will reduce your output. Now, what do you get at your homes? You get adverts of companies claiming that your system, that the system they will produce, will give you almost 1,800 kilowatt hours per kilowatt peak. In other words, the PV system is able to convert 90% of the solar potential into electricity. You only need a miracle to do that. It's impossible. Because if you only consider the temperature effects on the output of the PV system, you already have a 10% drop there. Then you have reflection from the modules. Not all the sun penetrates the modules. You have the quality of light. Not all types of lights, not all the frequencies of light can generate electrons within the cells. Only the UV radiation and part of the visible light are able to produce electrons to generate electricity from PV. 40% of solar radiation is incapable of generating electricity. That's the infrared radiation. So it's impossible and unbelievable how until today we get these figures claiming that their systems can produce over 90% of the potential of solar energy. The second myth that people come and talk to me about is we provide polycrystalline systems. They are more adaptable for hot weather, like Malta. The magic word here is crystalline. If the cells are made of a crystal silicon, then the characteristics of that silicon cell is the same, whether it is one crystal or multi-crystal. Look at the specs of the modules. You can find them on the internet. And you will immediately find that what we call the power loss coefficient, that means how much degradation, how much drop in power you get per degree rise in temperature above 25 degrees, it is roughly minus 0.45% per degree rise in temperature. Whether it is monocrystalline or polycrystalline, it's always within that range. So this second myth is also a mistake. The third one, they tell you thin film cells are not affected by temperature rise. It is not perfectly true. They are affected by temperature rise, but they are affected half as much as the crystalline silicon. Fair enough. So they are less affected by temperature, which means they can produce more power. Unfortunately, so far, thin film cells have roughly 2/3 the efficiency of a crystalline silicon cell. What does it mean? When the efficiency drops, it means you need more area. So instead of filling only 1/4 of your roof, now you have to fill half of your roof to get the same amount of energy. So, and this means you will need more cables, more connections, and therefore the eventual price will roughly be the same. Is it worth to go to a thin film system? So far, in my opinion, in areas, in countries like Malta, where area is an issue, where area is very important and expensive, thin film cells find less chance of being popular. The fourth myth is PV is maintenance free. That is not always true. Number one, you need to clean the panels. If you don't clean the panels, it depends where you stay. Where is your house? Where is your building? If you are close to a main street, you don't only get dust, you get soot from diesel engines coming and depositing over these modules. Soot and black color reduces the output tremendously. If you are in an area where it is dusty because of a quarry, that's another issue. If you are in an area where the dust is brownish, it's not a big issue. You still get a drop, roughly 5%, if you don't wash them. But in case of soot and close to main roads, you can get much higher. So it is part of maintenance. You need to wash them. You can't install PV in such a way that you can't reach them at all. Inverters. Inverters do fail. They will eventually fail. And the probability of failure is higher as they get older. Roughly after 7 to 10 years, you would expect to start changing the inverters. We don't get this experience so far in Malta because the bulk of the inverters are still new, only 4 or 5 years old. Modules also fail. It's not because I get you a guarantee of 25 years, it means that it is guaranteed 25 years with no failure. They are just guaranteeing that if it fails, they will replace it. Okay? We will talk about that later on. However, the problem will be, can you find in 5 years' time or 10 years' time the same model and the same shape, the same size of panels so that you can replace it perfectly with no effect, negative effect on the output? What's important is to realize that PV systems are silent. If you don't monitor them on a daily basis, you have a very good chance of losing months of power, of generation, simply because you didn't realize that somebody switched off the switch, or the switch went off on its own and you didn't realize, or something went wrong and nobody knew about that until your electricity bill comes and you see that the PV is 0 and you say, yeah, why do I have a system? The fifth myth is that microinverters are the best. Now, we know microinverters is the dream of the photovoltaic industry to produce AC modules. That means for every panel, you have an inverter integrated in the panel instead of the connection box at the back. That's perfect. You will eliminate many problems. But so far, the prices are still high. And therefore, because of the issue of prices, microinverters cannot be the best for all cases. So far, microinverters are interesting in places where the roof is partially shaded, where some of the modules will be partially shaded for part of the day, because if you put microinverters for each module, then you have a better chance of getting more output. I have 10, okay? I have time? Okay. PV is better than solar heating. Of course, it depends how much hot water do you consume. If you are a single person or two persons who are rarely at home and they don't consume hot water, of course, PV is better than solar heating. But if you are a family, 3 or more adults in the house, you use normal amount of hot water, which comes up to roughly 1,000 units of electricity per year because you have a geyser or something. So we are talking roughly once a day shower, not baths, and basically just the basics, okay? Solar heating still makes sense. The most important thing of solar heating is that it is a means of storage. You are storing hot water. Okay, you can have photovoltaics, sell the electricity to Malta, but when you need to heat your water, you will switch on the electricity, and the electricity will come from the grid. You are not storing the energy. You are still creating a problem for the grid, because if everybody does that, then the overloading on the grid will still be there. You are not relieving the grid from that, how can I say, source of energy which you can get directly from the sun without converting it first to electricity and then to heat. Even this process of converting sun to electricity to heat is very, very inefficient. While if you convert the sun's energy to heat directly, the efficiency is much higher. Solar heaters, in order to produce the same amount of energy as a PV system, occupy much less space on the roof, and actually they are still half as cheap, 50% cheaper than photovoltaics. Nowadays, the families come to us at the Institute. I want PV because I want to start using my AC system in summer. I haven't been using it for the past 3 years because of electricity bills, and now I want to start using it. That's very dangerous. Very dangerous for the country, very dangerous for the user. Why? Because you would be assuming that the PV system is covering all your electricity consumption in the air condition. It's not true at all, because the sun in the morning at 10 o'clock is not as strong as midday and is not as strong as 2 o'clock in the afternoon. But if you put your air condition on from 9 o'clock till 3 o'clock or at any other time, you are not perfectly matching that input or that output, and therefore you are running into the risk that after all, when your electricity bill comes, not all the electricity of the photovoltaic system is being fed into the grid at the high feed-in tariff of 22 cents, but actually you are using it at home at 18 cents. And if you have a very big PV system, you will end up selling it to Malta at much cheaper than 22 cents, because that is what they call the spill-off tariff. So it's not a straightforward solution. It is much better if you combine your PV system with an energy efficiency solution. Why is your room hot? Because the roof is not insulated, because this western wall is single wall. then you should invest to insulate that wall in order to reduce your air conditioning load. That makes more sense. The eighth myth is that just install the maximum size you can afford, because at the moment they are giving me 2,500 euros, so I want to maximize the benefits from the government. It will not work, because in 6 years' time, the feed-in tariff will drop to the spill-off tariff, which is much lower. And if you are producing a lot of electricity, you will end up, of course, because this electricity is being sold to an Malta in the morning and you need electricity at night, you will be selling it at a cheap price in the morning, buying it at a more expensive price in the evening. And I leave it to Professor Cilia to tell us what his trick is in that. Myth number 9, certain PV modules are not of good quality. So we get people complaining or doubting the quality of PV modules in the market. Now, if these PV modules have been approved by MRA, then they have passed certain European norm standards. For example, regarding safety, wind loading, hail resistance, and so on. Then there are extra tests, extra standards, where certain PV modules can also be resistant to salt mist. So if you live very close, we can say that Malta is a coastal island. There is salt practically everywhere, especially on windy days. But if you are very close to the coast, you have to be careful what type of panel to buy. It doesn't mean that because you bought some model and it started deteriorating, it was a bad panel. It was just not suited for your climate because you were very close to the beach. The same is for industrial areas. There are certain panels that have certain protection against chemicals. The biggest problem is not of the modules, but how the modules are installed, how they are clamped to the structure. And when a bufura rih, when a wind comes and we see hundreds of panels flying, it's not the panel itself that is defective, but the way it was stuck to the roof, the way it was connected to the structure, and so the problem is not really the panel. The 10th myth is they are guaranteed for 25 years. Of course, but please read the fine text. The real fine text. Now, some panels are guaranteed for 25 years, but the fine text at the bottom, they tell you in coastal regions, it's only guaranteed for 10 years. Okay? When you talk about inverters, certain long lifetime guarantees on inverters, they tell you they don't include European islands. Now tell me if Malta is a European island or not. Certain inverters with long lifetime guarantee, they tell you our guarantee is valid for so many years, only if you give us monitoring, 24 hours monitoring of that inverter throughout the lifetime of the inverter. Otherwise, the guarantee falls down to 5 years. So these are the things that one has to think about. Having said all that, photovoltaics is still a very sound investment. It's very safe to invest in photovoltaics. Okay? The current costs indicate that grid parity is imminent. We can get our payback period lower than 6 years, even without government grants. These myths and these tricks that suppliers tend to use will eventually destroy this relationship. We have to be careful. If we want to compete in the market, let's compete on better reasons like service, like after-sales service, and things like that. Customers need to know more on photovoltaic systems. It's very rare that we get to know. We have people who are complaining of PV systems, and when we ask them what type of system you have, they don't know anything. Were you given a user manual? No. So there are many things missing and lacking, which I hope will not reflect negatively on the market of photovoltaics in the coming few years. And in my opinion, the future grants on photovoltaics should no longer be on pure photovoltaics, but should also provide mandatory. If you want to take the grant of photovoltaics, you have to take another grant, which I can offer you as a government. You can choose either a solar heater, or insulation of your rooftop, or insulation or double glazing or shading. I will give you grants, but don't take photovoltaics on its own, because photovoltaic on its own will not solve our energy problem.